Little video. Today we're going to be looking at sample space and compound probability. We're going to start here by looking at sample spaces. First, we got to understand a few little definitions. My first definition here is for sample space. Sample space for an experiment is the set of all possible outcomes. So we got to go through and just list everything there is. The next one we have here is compound event. A compound event is an event that consists of two or more events. So two or more things are going to be happening. To find the probability of a compound event, well, that's kind of important. To find the probability of a compound event, we're going to find the probability of each event, so each event, and then we're going to multiply them together. And we'll look at that in just a minute here. And our first example here says, list the sample space of tossing 3 coins and find the probability of each. And then write your answers in fraction form. So we're tossing 3 coins here. So all 3 coins could land on heads. The first 2 could land on heads, and the third one land on tails. First one heads, second one tails, third one heads. And then I could have heads, tails, tails. Then I could have tails, head, heads, tails, heads, tails. And then I could have tails, tails, heads, and then tails, tails, tails. So how many possible things are there? Well, let's see. There is 1, 2, 3, 4, 5, 6, 7, and 8. 8 possibilities. We could have also come up with that by saying, for the first coin, there are 2 possibilities, times 2 possibilities for the second coin and 2 possibilities for the third coin, and we can see that there are going to be not 12, 8 possibilities. But we need to have our sample space so we can understand where everything goes. So we know our denominator is going to be 8. So I look at that and say, okay, I've got 8 right there. How many times do I have all 3 of them being heads? Well, I only see 1, so it's 1 out of 8. Our instructions say write our answer in fraction form. So we're done. The answer to this one is 1 over 8. The next one says the probability that we have 2 tails. It didn't say where they had to be, just 2 of them had to be tails. So we know our denominator has to be 8 again, so I'm going to put 8 on the bottom. And I'm going to go through and see, well, there's 1, 2, 3. 3 of those. So my final answer is 3 over 8. Can't be reduced. Leave it there. My last one they're asking for right here says the probability of 3 tails. Well, that only happens 1 time, so therefore my probability is just like the first one, 1 over 8. Our next example says the first 2 are heads. First 2 are heads. That happens 2 times. 2 different ways that can happen. So therefore that would be 2 over 8, which reduces to 1/4. And the last says the last 2 are tails. The last 2 are tails. I see 2 possible solutions for that. So there would be 2 over 8, which again is 1 over 4. You can go through and list your sample space of everything, and then just count the probabilities. Count what the good stuff is. Looking at our next example here. It says Ray spins a spinner and flips a coin. The following probabilities. Find the following probabilities. There we go. We'll get it spit out in a minute. Write your answer in fraction form. Since the probability of heads, of spinning a 1 and rolling a heads. Well, there are 6 sections here, so the probability of getting a 1 would be 1 out of 6 times the probability of landing on heads. Well, that would be 1 out of 2. So now we just multiply our fractions straight across. So 1 times 1 is 1. 6 times 2 is 12. And we're going to do that for each one of these examples. For our next one here, it says the probability of an even number. So I'm going to do the probability of getting an even number. Well, there's 1, 2, 3 even numbers, so that's 3 out of 6 times the probability of tails. Again, that's 1/2. You can always reduce your fractions before you multiply. Make your life a little easier. That reduces to 1/2. So I have 1 times 1 is 1. 2 times 2 is 4. So that one comes out to be 1/4. My next one here says the probability of getting a number less than 4 and landing on heads. So probability of getting a number less than 4 is going to be, well, let's see, there's 1, 2, 3, 3 of them less than 4. So 3 out of 6 times the probability of landing on heads, still 1 out of 2. Remember our 3 over 6, that reduces to 1/2, which would again be 1/4 once we multiply. My next one says the probability of 5 or larger. So the probability of 5 or larger, well, there are two numbers that are 5. There's 5 and a 6, so that'll be 2 out of 6 times the probability of tails. That's still 1/2. Remember, you can reduce your fractions. This becomes 1/3. I multiply straight across when dealing with fractions. 1 times 1 is 1. 3 times 2 is 6. So 1 out of 6 is our probability of that happening. Our next one here says the probability of getting a 7 and a heads. Well, the probability of getting a 7, well, I do not see a 7 on my spinner, so that's going to be 0. And this is still 1/2, and it doesn't matter what the second probability is. If you're multiplying it by 0, the answer is still 0. Looking at this next one, says the prime number. Well, prime numbers are 2, 3, and 5. So that would be 1 out of 2 times the probability of heads is still 1 out of 2. So 1 over 2 times 1 over 2 again is 1/4. Example 2. So moving along, continuing with our probabilities. Our next one here says compound events are either independent or dependent. Now that's kind of important. Independent and dependent. Independent or dependent. Independent events. If whatever happens the first time does not, well, that's kind of key right there, does not affect the outcome of another. Now, dependent event, if our first thing happens and it does change the outcome of the second one, that is dependent. So looking at example 3, it says Taylor draws 3 marbles from a bag that has 3 red, 5 blue, and 2 white marbles. He replaces the marble after each draw. What is the probability he draws a red, then a blue, and a white? Write your answer as a fraction, and then is this event independent or dependent? Well, the key word right here is that he replaces. That means he pulls it out and looks like, oh, cool, I got a marble. Writes down what he has, puts it back in the bag, and shakes it up again. If he's replacing it, that makes it an independent event, because the bag of marbles has not changed from the beginning. So the first thing we're looking at here says, I've got to find my probability that he is getting a red marble, then a blue marble, and then a white marble. So the probability of getting red, well, there are 3 red marbles out of a total of 10 marbles times my blue marbles. I have 5 of those out of 10 marbles in the bag because my bag has not changed, times there are 2 white marbles out of 10 marbles. Again, remember you can reduce your fractions before we go to multiply. This becomes 1 over 2. This one becomes 1 over 5. Makes life a little bit easier. So I have 3 times 1, which would be 3, over 10 times 2 times 5, which is 100. So the probability of Taylor drawing out a red, then a blue, then a white marble after replacing them is 3 out of 100. Not very good probability of it happening. Now in our example 4 here says Taylor draws 3 marbles from the bag, same bag of marbles here, but this time he does not replace them. Key phrase, does not replace. Pulls it out and says, oh cool, I got a marble. I see he sticks it in his pocket. Therefore my bag of marbles has changed. It is not the same bag of marbles every time. So now the first time I go to it, I still have 10 marbles in my bag. But this time I pulled a marble out, so the second time I go to the bag, there's only 9 marbles. And the third time I go to the bag, now there's only 8 marbles. The marbles change each time. This one is an independent event. I'm sorry, dependent. It is dependent event. It is a dependent event because each outcome changes what's going to happen the next time. So now I'm still looking for the same red, blue, then white. So to start with, my first probability is not going to change. It's still 3 out of 10. This time I've looked at it and said, okay, I put those down there. I only have 9 marbles left. I didn't take out a blue marble, though. I took out a red marble this time. So I still have 5 of these. So I have 5 out of 9. Next, I'm looking for a white marble. I still have 2 white marbles because I have not taken any white marbles out. But there's only 8 marbles in the bag. Now I gotta go through and I can reduce again, just like I did last time. Here I can reduce across the way, so I can take a 2 and a 5, makes my 10. Here I can take a 3 out of my 9, leaving 3 here and 1 here. So my numerator, the number on the top, 1 times 1 times 1 gives me just 1. My denominator, the only thing left is 3 times 8, so that is 24. So I have a 1 in 24 chance of picking a red, then a blue, then a white, if I pull one out and not replace it each time. Independent and dependent events. As always, pay attention to what you're doing, and good luck.